blanks, fill in the Venn diagram. It says there are 28 students in the class. So what that means is that the entire box holds 28 kids. So there's 28 kids in this box. And they either like jazz or country or both. All 28 like something. It says that in the problem. Each of the 28 likes something. Draw a Venn diagram showing how many students like only jazz. All right, so 18 kids like jazz. And 14 like country. Where do I put the 18 and the 14? We got a little bit of a problem here. There's 28 kids in the class. I said, how many of you like jazz? And 18 hands went up. I said, okay, now how many of you like country? 14 hands went up. What's the problem? That's more than I have kids, which means what had to happen? Some of them voted twice. How many voted twice? Well, how many hands went up? 32. I only have 28. So 4 kids must have voted twice. Now, those 4 like jazz. There are 18 total that like jazz. So there must be 14 here to make a total of 18. These 4 also like country. There's 14 total who like country, so there must be 10 there. Notice 14 plus 4 plus 10 is 28. That's everybody. Now we can answer the question. How many like only jazz? Only jazz is 14. These guys right here like only jazz. Okay? Quick probability question. Here's my box of kids, 28 kids in here. I reach in and grab a kid. What's the probability he will like both? 4 over 28. Aren't there 4 kids that like both? And there's 28 kids total. So the probability would be 1/7. Matthew, why are you so tired, sweetie? You just had 4 days off school.
Yeah.
All right. All right, number 5. Draw a Venn diagram. Oh, it's already drawn for you, but we're going to fill it in. Now this involves some new notation. Let's say that A stands for apples and B stands for bananas. What this says is the probability that someone likes apples is 0.6. The probability that someone likes bananas is 0.5. And the probability that someone likes both, this is and. That symbol, that upside down U, is the and symbol, the intersection symbol. So the probability that somebody likes apples and bananas, so both, is 0.2. Now you should be able to start the Venn diagram based on this right here. Because what area of the Venn diagram does that describe? The middle. That's the football in the middle. So you're going to put a 0.2 right here. That is the probability or the percentage of people who like. What in the world are you doing?
It was an emergency.
An emergency?
Yes.
Okay, when there are emergencies, you tell the teacher, and then you can step out in the hall and do whatever you need to do. You don't just sit back there on your phone when I'm talking.
Sorry.
Infraction. All right, here we go. So the probability of A and B is 0.2. Yeah. Now, we said the probability that somebody likes likes apples is 0.6. That means that this whole circle is 0.6. These are the people who like apples. But if 0.2 of them are already in the chart, then this part must be 0.4, because the whole apple circle is 0.6. But 0.2 of them are already there, part of the circle. So this is 0.4. Does that make sense to everybody? Similarly, the whole banana circle is 0.5, but you already put 0.2 in here. They're in the banana circle too. So how much is this? 0.3. Right? So the probability that somebody likes just bananas is 0.3. Now, I want you to add these up. What do these add up to? 0.9. Now, that's a problem in probability land, because all of your probabilities have to add up to 100%. So if I've got 40% here, 20% here, and 30% here, where are the other 10%? They don't like either one. They're out here. So 10% of the people don't like either bananas or apples. Got it? Probabilities gotta add up to 1, always. Or 100 if you're doing percentages. Have to add up to 100. All right, let's answer the questions now. Remember, the upside down U means and. So this little hash mark means not. So we're looking for the probability that you will like apples and not like bananas. So basically, you like only apples. Apples and not bananas. So what's the probability? Right from your diagram, you should be able to tell where are the A's but not B's located. Right here? So that's 0.4. Okay? What does this say? Not apples and bananas. So I like bananas and not apples. So that would be 0.3. What does that last one say? Don't like apples and don't like bananas. So what's that? That's the outside. That's 0.1. Okay, that's new notation, very different notation. But do you sort of get it? Because we're going to do another one now. Same thing. this is the one that I messed up the letters. It's not C's and B's, it's C's and D's. So I messed up the questions, I remember that. I need to fix that. So here's C, here's D. Probability of C is 0.75, probability of D is 0.4, and the probability of C and D is 0.35. Okay. All right, so where do you start? The middle. This is the only number that you can fill in the chart. The other ones can help us, but that is the only number that goes in the chart. The middle goes in the chart. So C and D is 0.35. This 0.75 does not go in the chart because the 0.75 represents the whole circle, right? The whole thing is 0.75. But you've already used 0.35. So what is this part? 0.4. Yep, 0.4. And the whole D is 0.4, but you've already done 0.35, so this must be 0.05. Okay, what do these add up to? Your whole chart only adds up to 0.8, which means that there are 2 people out here, or 0.2 people out here, who don't like cabbage or, what's a D food? I can't even think of one.
Donuts.
Donuts. They don't like cabbage or donuts, these people out here. All right, let's answer the questions. What does this say? What's the probability that somebody will like cabbage, but they won't like donuts? 0.4. What's the probability they won't like cabbage, but they will like donuts? 0.05. And what's the probability they don't like either one? Remember, the little hash means not. They don't like cabbage and they don't like donuts. That's these guys. That'll be a test question. Everybody sort of on board there? All right, we have one more thing to learn, and we're going to start reviewing. The last type of probability we're going to look at is conditional probability. So let's read question 7. That's where I am, right? Question 7. Let's read question 7. 2 things are going on. It's either going to rain or not. We're going to do homework or not. If it rains tomorrow, the probability Joe will do his homework is 40%. If it doesn't rain, the probability of his doing homework is 10%. Given that the probability of rain tomorrow is 30%, find Joe's probability of doing homework. We're going to build a tree diagram. It's going to have 2 branches. It's going to have a rain branch, and it's going to have a homework branch. When you do one of these, the question that's asked is your second branch. So the actual question is probability of doing homework. So homework is my second branch, and rain or not rain is my first branch. So let me say that again. In these problems, there's always going to be at least 2. For us, just 2 things going on. In this particular problem, we have rain or not rain, we have homework and not homework. You're going to stack these. One's going to come first, and then the next one's going to come second. The one that comes second is the question. So the question involves homework. So we're gonna have homework and not homework on the second branch of our tree. So we start with rain or no rain, and then we branch out from each of those, we branch out into homework or no homework. Homework or no homework. You're not going to get the right answer if you don't stack them right. So make sure you read the problem all the way through, and whatever the question is about is last. It's on the bottom. Okay? All right, let's fill in some numbers now. If it rains tomorrow, so if it rains tomorrow, the probability that Joe will do his homework is 40%. So this is a 0.40%. If it rains, doing homework, 40%. If it doesn't rain, the probability of doing homework is 10%. So if it doesn't rain, homework is the homework branch is 10%. The probability of rain is 30%. Now, I gotta fill in the rest, that's it, from the problem, but I gotta fill in all these other branches. Any idea what goes here? 70. 70. Because your probabilities have to add up to 100. So if there's a 30% chance it's gonna rain, there's a 70% chance it's not, right? Okay, what about here? 60. If there's a 40% chance he's gonna do the homework, there's a 60% chance he's not. Same thing here. This one's gonna be 90.9, 90. These little deals have to add up to 1. The V's have to add up to 1. Now, the question is, find Joe's probability of doing homework. Well, Joe can do homework here, and he can also do homework here. Would you agree with that? That there's 2 ways he can do homework. He can do homework on this branch of the tree, or he can do homework on this branch of the tree. This branch represents rain and homework. It's going to rain and he's going to do homework. What do I do when I say and? Multiply. So this branch is 0.30 times 0.40, which is 0.12. If my math is right, you've got a calculator. I've got a calculator, I guess. Now, what about this branch? Well, this is it's not going to rain, and he's going to do his homework. Not going to rain, and he's going to do his homework. So this one's going to be 0.70 times 0.10, which is 0.07. Now, there's 2 ways Joe can do his homework. He can do his homework on a rainy day, or he can do his homework on a not rainy day. What do I do when it's an or? I add. So the total probability of Joe doing his homework is 0.19, 19%, 0.19. Now, before we start the next one, I want you to tell me what is confusing. Is anything confusing about that chart, or where I multiplied, where I added, where I got the numbers? Easy? All right, number 8. What's going on in this problem? We got noodles and salad. Those are your two things. Noodles, not noodles, salad, not salad. Okay, which one comes first? Which one's going to be the first little branch of the tree there? Noodles. Yep, noodles come first. So this is noodles and not noodles. Then we can have salad or not salad. Are we straight on why noodles was first? Okay. All right, let's start filling in some numbers. If the cafeteria serves noodles, so if we have noodles, there's an 80% chance that we'll have salad. So I'm going to put my 0.8 right here. Are you good with that? Noodles and salad. If they don't serve noodles, there's a 50% chance. Given that they serve noodles just once each school week, what does that mean? How many, there's what? Exactly. How many days are there in a school week? 5. They're serving noodles once. So what's the probability of having noodles? 1/5 or 20%. So we have noodles 20% of the time. Sometimes you gotta figure this out, guys. Sometimes they don't give you the specific number. You have to kind of use your logic. 1 out of 5. 20%. All right, now the rest of the chart. Here we go. What goes over here? 80%. What goes here? 20. And what goes here? 50. Now the question is, find the probability we will have salad. So we can have salad here, or we can have salad here. So we're going to find those two numbers and we're going to add them together. Because we can have salad here, or we can have salad here. Now, this one means noodles and salad. So 0.2 times 0.8, I'll leave the zeros off. You can put them in, doesn't matter, using calculator. 0.16. Or I can go this route and not have noodles and still have salad, so that's 0.4. Now I'm going to add them together. 0.56. So there's a 56% chance on any day that you're going to have salad. All right, try the last one on your own. Let's see how far you can get with playing lacrosse and soccer. See if you can get your tree diagram set up correctly. you start with on your first rung of your tree, Michael?
Not quite there yet.
Okay, well, that's because you're screwing around. Because this is the very beginning of the problem. Somebody help me now. What goes first? Lacrosse. And then second will be soccer or no soccer. And we know that because the question asks, find the probability of playing soccer. Oh, wait. The question says, find the probability of playing lacrosse. This is backwards. Yeah, I believed whoever told me that. So nope, gotta fix it. Gotta fix it, can't get the right answer. Remember, whatever the question is, goes last. So since the question is lacrosse, then that is going to come last. Okay? And then first is either soccer or no soccer. So since we had some confusion about that, let me say it again. Read the question all the way through. Whatever ultimately you're asking about has to come last. Because I need the probability of playing lacrosse. So I need this one and I need this one. So I gotta fill in my numbers now. Are you with me? All right, so I'm gonna fill in my numbers. The probability that a student plays lacrosse if he plays soccer is 0.62. If he plays soccer and he plays lacrosse, 0.62. The probability that he plays lacrosse if he doesn't play soccer is 48.48. The probability that a student plays soccer is 0.7. Then you gotta find the purple branches there. All right, so Olivia, what's this one? Yep, 0.30 or just 0.3. You don't have to put those zeros on, but you certainly can, and they'll make any difference. All right, what's this one? Ethan?
Yes.
0.38. 0.38. And finally, what's this one? Madeline? Remember, you don't have a calculator for all this arithmetic, so don't get all hung up on that. If you're struggling with it, you can use your calculator. Now, how do I find the probability of this branch? I've got two numbers on this branch. I've got to start at the very top and come all the way down. So I have 0.7 and 0.62. What do I do with those two numbers? Multiply. So I got 0.434. This means I am playing soccer and I am playing lacrosse. This one means I'm not playing soccer, but I'm still playing lacrosse. So what's that one? 0.144. And since I can play lacrosse either way, I can play lacrosse with soccer or without soccer. I'll add these. .578 is the answer to the question. That is the total probability of playing lacrosse.
Would it be wrong if you put it into percent or percentage?
Nope. Nope, I told you that first thing. Now wait, when you say rounded, that would be 57.8%. Yeah. Don't be rounding at all. Alrighty, perfect. Now, I know there's more to your notes, but that's the next unit. So put those away in a safe place. No, we're not taking a break. Your homework for 9.3. Is due on 9.3. And 9.3 is 2 different pages. So 9.3 is a 2-section homework because there's more kinds of probability. So that will be due on Thursday. Okay, both of those are due on Thursday. All right? So I think I called it 9.3 number 1 and 9.3 number 2. Those are due on Thursday. Everybody hearing me? 9.3 number 1, 9.3 number 2. They're both due on Thursday. Okay. Now, let's get out our practice tests and we're going to start reviewing. I handed these out some time ago. I don't remember when. While you're finding those, I'm going to hand out our quizzes and see who's got a question about those. Some of you guys got perfect papers. Take it home and hang out on the fridge. Alright, you should all be starting on your practice test. We're going to get together here on it in a minute. If you're struggling with some of your homework, pay attention as we go over the practice test. That might clear some things up for you. I think 10.
Yes.
It's like kind of confusing at first. I was looking at it the other day and I was so
Marvel does really bad. All of the TV Hawkeye. I love Hawkeye.
I was not like
I liked it enough to watch it, but
All right, before we put anything away, does anybody have a question about the quizzes I turned back. Gabe?
How much was your out of?
10, I believe.
So if you missed 2, would that be 8?
Well, since there was a bonus, it would be 8.
So would the bonus make it 9?
No, the bonuses were 2.
Oh, okay.
So you could have gotten 12 questions, or 12 points, if you got everything perfect. I doubt it, because we have tests coming up. Okay? Is it?
Yeah.
Well, we'll have a quiz next week for sure.
Just come over and Oh, you're right.
Okay,
Thank you.
all right. No questions on the quiz? If you missed something, you got it?
Oh, I have a question.
What?
Teamwork is gonna be wrong.
It's probably not wrong, right? What's the question?
How many ways can you arrange letters or the word Robert?
So the word is Robert. And what did you say the answer was?
7
How did you set it up?
just 6 factorial.
And that would be a great way to start, but there are 2 R's, right? So it should be 6 factorial, 2 factorial, which would be 360. Okay, anything else that we need to talk about in terms of those quizzes? All right, practice test 1. We're going to get as far as we can. Here we go. Answer the following. Use your calculator to evaluate. Round to the nearest thousand if necessary. It's time to focus now. Remember, review days are my gift to you. I can take the gift back and we can just take a test. I know you do, but not all of you are paying attention. How many ways can 7 books be arranged on a shelf? Start with 7 factorial and then type that into our calculator. And that's one I should know. 5,040. There will be an answer blank on the test, and you will write 5,040 in the answer blank. But the way you get that is by doing 7 factorial, right? Okay, next question. How many outfits are possible if you have 4 pairs of pants and 6 shirts? 4 times 6, 24. There are no factorials. We are not arranging. We're picking a shirt. We're picking a pair of pants. 4 times 6, 24. How many ways can you answer 8 true-false questions? Now think about this for a second. Think about each question. What do you think? 2 to the 8th. She hasn't even been here and she's got it. 2 to the 8th. Because here's the first question. This is just the first question. How many choices do I have? 2. All right, now I'm on to the second question. How many choices do I have for it? 2. So don't I have 2's in all these blanks? And since I have to answer question 1 and 2 and 3 and 4, I'm going to multiply them. So I'm multiplying 2 times 2 8 times. Yeah. So 2 to the 8th, or what is that? 256. In how many ways can I give a pencil, a marker, and an eraser to 3 students in a class of 12? 12P3. Okay, now remember, anytime you have a big group and you're picking a few out of the group, it's a P or a C. Big number must come first, so 12P3. Why is this a P and not a C? Order matters because the prizes are different. If if I were given everybody a pencil, same situation, but everybody gets a pencil, that's 12C3. Because order doesn't matter if you're all getting the same thing. All right, what's 12P3? 1320. So 1,320 ways. Remember, you ultimately have to type it into your calculator. So writing 12P3 that's the work that you need to get the answer. All right, how many 8-letter words can be formed from the letters of prettier?
8 factorial.
I start with 8 factorial because there's 8 letters, right guys? And then I got 2 T's.
3 is the 2 factorials.
And I have 2 E's.
2 R's.
And I have 2 R's. Oh my goodness. Let's all type that in and make sure we get the right answer. You get half credit for setting it up and half credit for knowing how to type it in. Did you get 5,040?
I got like 80,000 something.
Okay. Okay. When you typed it in, did you remember to put parentheses here?
No.
That's why you didn't get the right answer.
Okay.
When your denominator has more than one thing in it, if it has just a 2 in it, you don't need parentheses. But when it has more than one thing, you must put it in parentheses. Now, did you get the right answer?
Yeah.
Okay. Question 6. Uh-oh, this is brand new. Can anybody tell me what's different about question 6 and all the other questions we've done? Man,
It's in a circle.
all of a sudden I just got cold. Is it cold in here?
No.
No, just me? Hope I'm not getting sick. Okay,
Is it they're seeing this circle?
exactly. Our other questions that we have done, I have asked you things like, how many ways can 10 people be seated in a row? And the answer to that question is easy, 10 factorial.
First of all.
When you put things in a circle, and I'm going to try to explain why here in a minute, but for right now, just listen to me. When you arrange things in a circle, it's 1 less factorial. So 10 people in a circle are 9 factorial. 10 people in a circle are 9 factorial. 8 people in a circle would be 7 factorial. It's always 1 less factorial in a circle. So the answer to the question is 362,880. Now I can't do it with 10 people because that's just too big of a situation. But let's say that I have 3 people. Let's say 4 people. I have 4 people and I'm going to arrange them in a circle. So that could be A, B, C, D, right? They can be arranged like that. But look at this for a minute, kids. What if I arranged them like this? Now they're in a circle. Is there any difference between that circle and this circle? No, because circles have no beginnings and no ends. Lines have a start and a stop. So A, B, C, D in a line is different than B, C, D, A in a line. Those are different because of the starting and stopping. Who's on the ends? But isn't person A between D and B here and here? These people haven't been rearranged. We just rotated the circle, but they're the same arrangement of people. No one's moved. Here, these guys got up and moved. These are in different seats, but not here. So circles are one less factorial. So you gotta pay attention if you're putting them in a line or you're putting them in a circle around a campfire. Okay, enough of that. Here we go. Number 7. How many committees consisting of 3 boys and 5 girls can be formed from a class of 10 boys and 8 girls?
Would it be 10C3?
I hear somebody saying something. 10C3, 8C5. And what do I do with those two numbers? What sign goes in between them? Multiplication. Because aren't I picking boys and girls? Does everybody understand this part? And this part? And I'm going to multiply them. So 10 C3 times 8 C5. Did you get 6,720? Why is this a C and not a P?
Because it doesn't matter.
Order doesn't matter. Committees, that doesn't matter. Committees are always C's. This one be on the table. Yep. What is the probability of being dealt a 5-card hand that is all diamonds? We talked about this last time. Probability is going to be a fraction. It's a 5-card hand. Denominator is 52C5. Because the denominator is the total. There are 52 total cards, and you're picking 5 of them. Now, the numerator is what you want, and you want all diamonds. So what's the numerator going to look like? 13C5. Yep. On test day, I will not answer card questions for you. You need to get comfortable with the deck. So 13C5 divided by 52. C5. Uh-oh. Did you notice what happened? You got an E? Pay attention, you got an E. So your answer is 4.952 times 10 to the negative 4, which you can leave like that, or you can write it as a decimal. It's probably just easier to leave it like that. It's 0.0004952. Nope. That one's the right number. All right. What is the probability of being dealt a 5-card hand that has exactly 3 aces? Isn't the denominator the same thing? It's 5-card hand. That's always going to be the denominator if it's a 5-card hand. Exactly 3 aces. What? It would be 4C3 because there are 4 aces and we're picking 3 of them, right? But boys and girls, this is a tricky one. It's a 5-card hand. If 3 of your cards are aces, what does that mean about the rest? There's 2 of them that aren't aces. So how many not aces are there total in the deck? 48. There's 52 altogether. 4 of them are aces. The other 48 are not aces. So of that 48, you need to pick 2. That is a tough problem. You have to pay attention. I need 5 cards. 3 of them are aces, so the other 2 are not aces. It's going to be another small number. Oh, it's not that small. Did you get 0.0017? Oh, look at problem 10. Does that look familiar? We just did. If it rains tomorrow, the probability I'll play tennis is 15%. If it doesn't rain, the probability I'll play is 90. If the probability of rain tomorrow is 45, find the probability that I will play tennis. Do you see how that's like the ones we just did? So what's going to go first? Rain and no rain. And I'm going to build on that and say, okay, I'm going to play tennis, or I'm not going to play tennis. Okay, fill in your numbers, see if you can get all the decimals put in there. And actually, go ahead and see if you can come up with a number. The answer. I'd love to hear some answers when you finally get to that point. I'd like to see if we agree or disagree. 0.1225. So 0.1225. All right. Anybody get anything different? You got that same thing?
I got
You
it.
didn't do it. Olivia?
I got, 0.5625.
0.5625. Okay, so Olivia is the only brave soul to speak up. Thank you, Olivia. Let's talk about it, because we got 2 different answers and maybe even more you guys can try. I put 0.45 and 0.552, is that right? And then I put 0.15 and 0.85 and 0.9 and 0.1. Does anybody have a question about the location of my numbers? Okay. So then it says, what's the probability that I will play tennis? Now, all of our examples have been, what's the probability I will do this? But I could also ask, what's the probability I won't play tennis? And then we would be looking at these, right? But this is another tennis one, so I'm looking at these. So I'm gonna take 0.45 times 0.15, I'm gonna figure out whatever that is. .0675. And then I'm gonna take 0.55 times 0.9 right here. And that's 0.495. I got that from 0.9 times 0.55. And I'm going to add those together. And I got what Olivia got. So Diane, did you find your mistake?
Yeah.
All right, we're going to do one more and we'll be done for the day. Number 11. There are 50 seniors in the chapel. They all enjoy singing and or praying. If 25 indicate they enjoy singing and 32 indicate they enjoy praying, how many enjoy only praying? What do you think we're going to do for this problem? Venn diagram. Don't you just feel like a Venn diagram there? We got people who like one of them, both of them, that overlap. This is a Venn diagram. So we've got 50 kids all together, and everybody either likes singing, praying, or both. $25 like singing, and 32 like praying. So imagine, I walk into the chapel, 50 kids are sitting there. How many of you like to sing? Up go 25 hands. How many of you like to pray? Up go 32 hands. Wait a second. What's going on there? Something's wrong. That's too many hands, right? So some like both. How many like both? 7. So you put a 7 right here in the middle of your Venn diagram. Now, because the whole S ball is 25, but 7 of them are already up here, that means there's 18 here. And because the whole P ball is 32, but 7 of them are already here, that's 25. We can answer the question. How many like only praying? 25. Like only praying. All right, we'll pick up there next time. Seems to me like